Hey guys, today we're going to talk about experimental design and identifying variables within our experiment. So this will be our first homework of the year. Hope you guys are excited to watch the video and answer some of the questions. So here we go. Okay, so let's start with an experiment. Let's say that Mr. Pites, who loves tomatoes, who loves to grow stuff, let's say that Mr. Pites wants to know if adding coffee grounds to his soil will make his tomato plants grow taller. This is the experiment that I want to run. I want to know how to grow my plants taller. Will coffee grounds help or hurt? So in this experiment with coffee grounds and tomato plants, we have three variables. Now, a variable is a part of an experiment that can either change or not change. They're what we measure, they're what we change, and there are some things that we keep the same. So let's look at the three types of variables that we can have. The first one that we're going to look at today is called the independent variable. So I like to call the independent variable the IV. The independent variable, guys, is something that you need to know. It is something that is changed by the scientist. It's what we are manipulating. It's what we're testing. Okay? So in this experiment, think about the experiment that I want to run with coffee grounds and tomato plants. What am I testing? What am I changing? What am I introducing into this experiment? So what is being tested in this experiment? What are we adding in? The answer is the coffee grounds, right? We're testing the coffee grounds. We want to know, do the coffee grounds help or do they hurt? Okay. So IV, it's what is changed by the scientist, changed by the experimenter. It's what we are testing. It's what we're manipulating. In this case, it's coffee. Next variable, the dependent. So not the independent, but the dependent. The dependent variable is something that is affected by the independent variable. So it's what changes because of the independent variable. So the easiest way that I remember the DV is it's always what you measure. Okay, it's what we are looking for in the experiment. Okay, so think back to our experiment that we talked about: coffee grounds and tomato plants. So what am I going to be measuring? What am I looking at to see what happens? So what is being measured in our experiment? It's the height of our tomatoes, right? If I add in coffee grounds, and I look to see if it impacts my tomatoes, I'm going to be measuring my tomato plants. Okay, third variable is called the control variable, the CV. A control variable is just like it sounds. It's what's controlled. It is what is not changed. So in our experiment, we've identified the independent, which was the coffee grounds. We added those in. That was changed, right? We changed the addition of coffee grounds. The DV was what we measured. It was the height of my tomatoes. And the CV, the control variable, is what must stay the same. This is what allows us to conduct what's known as a fair test. How do we know that our results are going to be reliable? So control variables are everything that is involved with this experiment that are not coffee grounds. So what must stay the same in our experiment for it to be fair? What about our growing of tomatoes should stay the same? Okay, everything other than coffee grounds. So some examples. How much water do we give our plants, right? Because we're going to have more than one tomato plant. What type of light, how much light we give our plants, right? If you change the amount of light, and you change the coffee grounds, how do you know which one impacted our plants? We don't know. So in order to make sure that it's the coffee that impacts them, we have to keep everything else the same. So water has to stay the same, light has to stay the same, soil, all your plants have to be in the exact same type of soil. If you provide fertilizer, that has to stay the same. Your plants have to stay the same, right? You don't want to put coffee grounds on a tomato plant and then a potato plant and measure them, because they're not the same plant. They might be impacted differently. Okay, so let's do some examples. So here's our first example. It says Elizabeth wanted to test if temperature affected how fast milk goes bad and curdles. Remember, when milk gets bad, it kind of smells weird and it gets kind of chunky. That's what we call curdling. So curdling means that the milk is gone sour, it's gone bad. So Elizabeth wants to see that, to see if temperature changes how fast the milk goes bad. So she leaves 50 milliliters of 2% milk in a room temperature closet. She also leaves that one in a fridge and also an oven that was turned on low heat. She then measured how much the milk curdled after 24 hours. So here we have our experiment. We have 3 glasses of milk. And think about this. I drew my cartons pretty much the same size. Why is that important? Think about why that's important, that I drew the milk the same. Okay? So her first one, she's got it in a room temperature closet. So room temp is something like maybe 70 degrees. She also put one in a fridge, right? Fridges are cold, right? But they're not frozen. So let's say that the fridge is, let's say, 38 degrees. And then on an oven at low heat could be something like, let's say, 150 degrees. So here we have 3 things of milk in 3 different environments, and we want to know what's going to happen to how fast they turn bad, how fast they get stinky. Okay, so let's identify some variables from our experiment. Independent variables. So what are we changing? What is being tested in this experiment? Think about it in your head. It's the temperature, right? It is undoubtedly the temperature. You saw the 3 milk cartons were in 3 different environments, right? We had room temp, fridge, and the oven. So we had different temperatures. So temperature is what is being tested. It's what's being changed. What about the dependent variable? Remember, the dependent variable is what we are measuring. If we go back, what is Elizabeth measuring in scenario 1, right? We put 3 things of milk in 3 different environments, and she is measuring what? Go back. It is how much the milk curdled, right? So we're going to be looking at how chunky it is, and maybe how much curdled milk, how many chunks we have in each of our glasses. And controlled. Now, if Elizabeth changed the temperature and she measured the amount that it curdled, what has to stay the same in this experiment? Things like 2% milk for each temperature, right? You don't want to use 1% skim and whole milk because they're not the same. She also used 50 milliliters of milk for each temperature. Remember, I drew each cup was about the same size. That's because you have to have the same amount of milk in each experiment, right? Because it cannot change. The only thing that can change is the temperature. Another example of something that was controlled is that each temperature was checked after 24 hours, so the time is controlled, right? She didn't check one at 8 hours, the other one at 16 hours, and the other one at 24 hours, right? She checked them all at the same time, 24 hours. Okay, so one more. Let's do one more. Scenario 2. How does changing the air temperature affect how the growth of Mr. Pite's basil plants? How does it affect the growth? Okay, so we're looking at my basil plants. How does changing the air temperature affect the growth of my plants? Right, because I'm a plant guy. So, independent variable, air temperature, right? If you think back here, where it gives it away, right? Changing the air temp, right? Something that's not staying the same is changing. So changing the air temp is our independent variable. What am I measuring then? If I'm changing the air temp, I want to measure the growth, right? The growth of my basil plants. And my control variable, if I change the air temp, what has to stay the same? Everything else. And in this example, type of plant, right? I use just basil plants, not basil and tomato and potato. Okay, just basil plants are my type of plant. Okay, so from here on out, guys, I'm going to have you guys design your own investigations, and you guys will do this in your notebooks. Here's the first investigation. This is what I want you guys to do first. So let's remove this. Okay, so it says the greater the amount of soap in a soap and water mixture, the bigger a soap bubble can be blown. So this is sort of our hypothesis. This is what we think will happen. If I add in more soap to a soap and water mixture, then we can have a bigger bubble. So what I want you guys to do is these three things in your notes. Number one, what are the variables? So the IV, the dV, and the control variable, the CB. Okay, so what will be changed? How will it be changed? What will be measured, and how will it be measured? So you're designing this experiment. What are we changing specifically, right? Kind of tells you up here. And what are you going to measure, and how will you measure it? Okay, so work on this in your notebooks, and we will go over it in class. If you have questions about this, please see me in class. If not, watch this video again, go through it again, go through more of the examples. Again, IV, independent variables, what changes, dV, dependent variables, what's measured, and the control variable is what stays the same. All right.